Hello guys, welcome aboard Apex Math. My name is Pino. In this video, we go through question 5 from the 31st July 2025 and 5 mathematics question paper. Question 5.1 states that the time t and velocity v of an object moving in a medium at a time t is given by the following integral. So we have to solve for the following integral so that we can evaluate the t. To solve this integral, we are going to use partial fraction decomposition. So let's isolate the integrand and decompose. So the decomposition will be equal. So since we have unique linear factors, the decomposition will be a divided by v plus b divided by 2v plus 1. And we have to determine the numerical value of a and b. So we do that by multiplying both sides of the equation by the denominator on the left. So we multiply by v into 2v plus 1. And what we do on the left, we do on the right. We multiply the right by v multiplied by 2v plus 1. And that v will cancel out with that v. The 2v plus 1 will also cancel out with that 2v plus 1 and will be left with 1, which will be equal. So we distribute that v multiplied by 2v plus 1 and we'll multiply it with the a divided by v. So we have a divided by v, which we multiply with the v multiplied by 2v plus 1. Now we multiply it with the b divided by 2v plus 1. So we have b divided by 2v plus 1, which we multiply with the v multiplied by 2v plus 1. And from here, we have that v and that v cancelling out, and the 2v plus 1 and the 2v plus 1, they divide to 1. And 1 on the left will be equal a multiplied by 2v plus 1 plus b multiplied by v. To determine the numerical values of a and b, we let v equal any two numbers, and from there we will have two equations which we will use to solve for a and b simultaneously. Or we can be strategic and let v equal specific numbers. If we let v equal 0, that 0 multiplied by b will be 0, giving us an opportunity to determine that a. So we let v equal 0. So when v is 0, that 0 multiplied by that b will also be 0. So we have 1 is equal a into 2 multiplied by 0 plus 1 plus b multiplied by 0. That 2 multiplied by 0 will be 0. Even the b multiplied by 0 will be 0. So 1 will be equal a multiplied by 1. So our a is equal 1. So we just determined the numerical value of a is equal 1. So let's determine the numerical value of b. So we can be strategic and let v equal negative half. So when v is equal negative half, that 2 multiplied by negative half will be negative 1, and negative 1 plus that 1 will be 0. And the 0 multiplied by that a will also be 0. So we have 1 is equal a into 2 multiplied by negative half in the place of the v plus 1 plus b multiplied by v, but in the place of the v we have a negative half. 1 will be equal a into 2 multiplied by negative half is negative 1 plus 1 plus b multiplied by a negative half. Negative 1 plus 1 is 0. 0 times a is 0. So 1 will be equal b multiplied by negative half. To solve for b, we multiply both sides of the equation by negative 2. Negative 2 multiplied by negative half will be 1. So negative 2 will be equal b. So now we determine the b so we can integrate. Remember, integrating this side with respect to v is equal to integrating this side with respect to v. So let me copy and paste this. Now that we have the numerical value of a and b, we substitute, and our integral is from 10 to 100. Let's substitute the a and the b. So we are going to have our a was equal 1. So we have 1 divided by v plus our b, which was negative 2, divided by 2v plus 1. We integrate with respect to v. So the integral of 1 over v is equal ln of v minus 2 multiplied by the integral of 1 divided by 2v plus 1, which will be equal the ln of 2v plus 1. But I suggest we use the u sub method. So when we use the u sub method, we let u equal 2v plus 1. The reason why I suggest this is because we will forget that 2. So when we differentiate, the derivative of the 2v is 2. We multiply when we differentiate, but when we integrate, we divide with that 2. When we use the u sub method, we won't forget to divide by that 2. The u sub method will only be used to solve this part of the integral. So we have our integral, our limit as 10 to 100. Let's simplify before we can substitute. So we have the ln of v minus, so that 2 divided by 2 will be 1, and we'll have the ln of the 2v plus 1 with our bounds from 10 to 100. So now let's substitute the v. So we start by substituting that smaller number. So we have the ln of 10 minus the ln of 2 multiplied by 10 in the place of the v plus that one minus, now we substitute the 100 where there is the v. So we have the ln of 100 minus the ln of 2 multiplied by 100 plus 1, and on our calculator, the first part, which has 100, will be equal negative 0.742, and the part of 100 will be equal negative 0.698, and this will be equal negative 0.044. And remember that this was our time, so our time cannot be negative. So let's remove the negative, so t will be equal 0.044. I'm just going to assume seconds, and this will be our answer. Question 5.2, we are given the curves y is equals to x squared and y is equal to minus x. 5.2.1, we calculated the coordinates of the turning points of intersection of these two functions. So to determine the coordinates of the points of intersection, we simply equate the y's. So we equate that y and y. So x squared will be equal the 2 minus x. We transpose the 2 minus x such that we will have x squared minus 2 plus x, which will be equal 0. Now we factorize the factors of the x squared will be x and x. The factors of the negative 2 will be positive 2 and negative 1. So our x will be equal negative 2, or our x will be equal 1. So we substitute them into either of the y's. So let's substitute them into this y. So where there is x, we are going to substitute the negative 2, and this will be squared. So negative 2 squared is equal 4. So the first point of intersection, when x is negative 2, y is positive 4. Now we substitute the x is equal 1. Where there is x, we substitute 1, and 1 squared is equal 1. So our y is equal 1. So the second point of intersection is equal 1 and 1, while the first was this negative 2 and 4. So we determined the points of intersection. Moving on, question 5.2.2, we make a neat sketch to show the enclosed area, the representative strip, and the points of intersection. So let's quickly draw. So we start with the y is equal to x squared. The coefficient of the x squared is positive, so we are going to have a smiling graph passing through the origin, and the graph y is equal to 2 minus x. This will be our graph. It has a negative gradient. The points of intersection was the negative 2 and 4. The first one was the negative 2 and 4, and the second one was the positive 1 and 1, and this will be our area. We have to draw the strip. The strip has to touch both graphs. When it's horizontal like that, it only touches one graph, but when it's vertical, it touches both graphs. So this will be our strip, which we name this strip as dx, and this will be our answer. Question 5.2.3, we calculate the magnitude of the area in question 5.2.2. So the formula for area available in the formula sheet, we have area is equal the integral from the point A to the point B of y1 minus y2. Sometimes they say y2 minus y1, but we have our area as equal the integral from point A to B. So point A will be where the enclosed area starts. It starts at that point of intersection where x is equal negative 2, and B is where it ends at that point where x is equal 1. We always start with the function which is at the top, and on our area, the function which is at the top is the linear function. So we start with the 2 minus x, and it will be followed by the function which is at the bottom, the x squared dx. Now the integral of the 2 with respect to x is equal to x. The integral of negative x is equal negative x squared divided by 2. The integral of negative x squared is negative x cubed divided by 3, with our bounds from negative 2 to 1, the x coordinates of the points of intersection. So our area will be equal, we substitute first the negative 2, so we have 2 into negative 2 minus negative 2 squared divided by 2 minus negative 2 cubed divided by 3. Now we substitute the 1, so we'll have 2 into 1 minus 1 squared divided by 2 minus 1 cubed divided by 3. So our area, the negative 2 part, will be equal negative 3,33, and the 1 part will be equal 1,167, and this will be equal negative 4,5. I think I was supposed to start by substituting the 1 and then the negative 2, because now our answer is negative and we cannot have a negative area. So our area will be equal 4,5 unit squared. Question 5.3, we calculated the moment of inertia of a uniform circular wheel of a diameter 300 centimeters about an axis through its center and perpendicular to the wheel. The mass of the wheel is equal 500 kg. I meant 50 kg. So we use the following formulas from the formula sheet. So we are going to use that formula and that formula. So let's copy these formulas from the formula sheet. So you have I is equal the integral from the point A to the point B of r squared with respect to the mass. And we also have the mass is equal density multiplied by volume. But we are told that we have a uniform circular wheel and we are given only the diameter without the height. So we are not working with volumetric density. Instead, we are working with area density. So here we multiply the density by the area. We write this formula with symbols. So we have M for mass is equal the density multiplied by the A for area. We still have the mass is equal the density, and the area we express it in terms of pi multiplied by radius squared, and we differentiate. The derivative of the m is equal 1. We multiply it by the dm so that we show that we differentiated mass. This will be equal the density multiplied by pi. The derivative of the r squared will be 2r, which we multiply with the dr to indicate that we differentiated the radius. So dm will be equal, we start with the 2 pi and then the density multiplied by the radius multiplied by the dr. We substitute this into this formula for inertia. So we have this as equal the integral from the point A to the point B of r squared. In the place of that dm, we are going to substitute the 2 pi multiplied by the density multiplied by the radius and the dr. So we substitute the 2 pi multiplied by the density multiplied by the dr. We are integrating with respect to the r. So we are given the diameter. So we convert this diameter to radius. We divide by 100 to convert to meters. So this will be equal 3 meters. And our radius, we divide the 3 by 2. And our radius will be equal 1,5 meters. Remember that this is our wheel, and we have the radius starting from the point, the center, which is 0 up until the edge, which is 1,5. So even our integral, it will be bound from 0 up until 1,5. And we can remove the parts which do not have r, since we are integrating with respect to r. So we remove the 2 pi and that diameter. We push them out of the integral. So we have 2 pi multiplied by density, and inside the integral we'll be left with the r squared multiplied by r, which is equal r cubed. And we have the dr. Now we integrate with respect to r. Our I will be equal 2 pi multiplied by density. The integral of r cubed will be equal r to the power 4 divided by 4 with our bounds from 0 up until 1,5 meters. It's only now that we are allowed to change that density. So you have I is equal to pi multiplied by the density. In the place of that density, we are going to substitute. So we make the density the subject of the formula here. So let's copy and paste this. We make the density the subject, so we divide by pi multiplied by r squared, both sides of the equation, m divided by pi r squared. So this will be our density. So let's copy and paste this. So in the place of the diameter, we are going to substitute the m divided by pi r squared, and we were given the m as equal 50 kg. So we multiply this by the r to the power 4 divided by 4, and our boundaries are from 0 to 1,5. We can cancel out a few things. The pi divided by pi will be equal 1, and the r to the power 4 divided by that r squared will be r squared, and the 2 divided by 4 will be 1 over 2. So we'll have m multiplied by r squared divided by 2 with our boundaries, the 1,5 and the 0. So we can substitute. So we have I is equal, in the place of the m, we were given m as equal the 50 kg. So that 50 kg, in the place of the m, we substitute the 50 kg. And we start by substituting the 1,5. This is divided by 2, but then the 1,5 is squared. So minus m multiplied by 0 squared divided by 2. So this will be equal, so our I will be equal 56,25 kilogram meter squared, and this will be our answer. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content interesting.